So how do you do pseudo-classical inheritance in JavaScript? This question is really asking to see if you know how to implement pseudo-classical object-oriented principles in JavaScript. Now, object-oriented programming and inheritance concepts in JavaScript are really hard to learn. Unlike languages like Java or C++ or Python, there are no standards, there are no core features of the language to support it. In ES5, there is no structure called a class, there is no keyword called class. There is one in ES6. But we can mimic, in a way, similar object-oriented programming concepts that are in use in languages like C++ and Java by the use of function constructors and the new keyword. That's what people mean when they talk about classical or pseudo-classical inheritance in JavaScript. They mean this method I'm about to teach you, which mimics in syntax and style the object-oriented programming paradigms of other languages like Java, C++, etc. Now, just as a reminder, what I'm about to describe to you is sometimes called pseudo-classical inheritance. It's sometimes called straight-up classical inheritance, which is incorrect, but people sometimes just say it anyway. Or more accurately and more properly, it's called the constructor pattern. So the first thing to know about this is something called function constructors. In other languages, we have this concept of a class. Think of it like a blueprint, a design for an object. The class describes the behavior of an object via member functions and also the state of an object via properties. JavaScript doesn't have any concept of a class, but we can kinda mimic one with something called a function constructor. Now let me start writing some code on the screen. Now the first thing I'm going to do is use strict, because by now you should know that we should always be typing in use strict at the top of a file. Then I'm just going to start typing a function. Now looking at it, it actually looks just like a standard, normal, everyday JavaScript function. And that's because it is a standard, normal, everyday JavaScript function. But what I'm going to do with this function is I'm going to take whatever parameters I've passed in and I'm going to assign it as a property on the this variable here. So the function above on its own doesn't look like a class. And if we try to call it, nothing much would happen. So I've created a variable called dude, and I'm calling person and I'm passing in Asim Hussein. So let's see what happens when I run this. Okay, we get an error. The error is uncaught type error cannot set property first name of undefined. And if you click on the line number, you can see it's actually erroring out on line number 4. So let me just pause for a second and I'm going to give you about 5 seconds just to think about why we may be getting this error. Okay, I gave you a little bit of time there. Did you get it? So if you remember from the previous lectures, by default, this is set to the global window object. But if we use useStrict inside a function, this is set by default to undefined. So we're trying to find the property first name on something that's undefined, and therefore we're getting that error. But if we tried using the new keyword, let me just put it in here. So just a slight difference to our statement there. Now we have var dude is equal to new person. Let's see what happens now. Let me clear the console and run again. No errors. Everything is absolutely fine. So this code seems to have actually created, well, or at least not errored out on line 8. Let's find out what's going on by debugging it. Let me drop a breakpoint on line 9, hit run, and then let's watch dude. you can see what it's created is an object, well, a person style object. If we open it out, you can then see that it's got two properties, one called first name with a value of Asim, and another called last name with a value of Hussein. What we've written above is somewhat similar to if we did var dude is equal to an empty object, and then we did person.call, and I pass in those two parameters, and then I pass in dude as the first parameter to the call function. And then if we were to console log dude again. So if you remember, every function has a function called call where the first parameter that you pass in, which calls the function, but the first parameter you pass in is what that function will use as this. So we create the dude object, we call the person function, but we set dude to the object that we've created. So that means that inside the person function, this will equal to the dude object. And then we just call it as if we called person with Asim and Hussein. And then we get the dude object with those properties attached. Let me show you. So if I run the snippet, there we go. We've got dude. It's got first name Asim and last name Asim. So very, very similar to what happened with when we did the new keyword. Now it's not exactly the same. I don't want you to walk away from this thinking that this new keyword is basically performing this activity here. It's not. It's actually doing a bunch of other things as well. But I just wanted to show you that what it's doing isn't really magic. It's doing stuff that you kind of already know and understand. Okay, so now we've got something that looks like a class, something that you might find familiar if coming from another language like Java or C++. We can add properties onto that class. So that is to say, we can add data to instances of that class. But how can we then have functions? How can we have member functions on our classes? Now there's two ways of doing this in the pseudo-classical approach. I'm going to show you both of them now, and they both have pros and cons. Let me delete this code first though. And then let me go back into our person function constructor or our person class. And here I'm going to add a function called full name, which just returns the first name and the last name concatenated with a space in between. So now if I wanted to just call that function, I could just call it by calling dude.fullName. So if I now debug this, you can see now as well as first name and last name, we have a function called full name which we can call. And if I was to continue execution, you can see on line 10, it prints out Asim Hussein, which is what we expect the full name function to print out. Okay, so that's one way of adding functions to classes, to our pseudo classes in JavaScript. Another way is using prototypes or function prototypes. Now, to understand what I mean by function prototypes, let's break down the statement var dude is equal to new person Asim Hussein. I'm going to go very deep now into the new keyword and just really show you exactly what it does. We create an instance of the person pseudo class by calling the person constructor with the new keyword. So we've created an instance called dude, and it has the properties of first name and last name as Asim and Hussein. But as we know, all objects in JavaScript have a prototype, a proto property. What does the proto property of our dude instance, what does it point to? To explain that, we have to understand that functions in JavaScript also have a property called prototype. Yeah, I know it can be confusing. We've got prototype on a function and underscore underscore proto underscore underscore on an object. So the prototype property of a function points to an object. This object has a constructor property which actually points to person itself. But also, because it's an object, it again has its own underscore underscore proto property. And just like all other objects in JavaScript, that points to another object and another object until eventually it just ends up pointing to null. So back to the question of what does the proto property of our dude instance point to? What do you think it points to? Honestly, think about it for a second. I'm going to give you 5 seconds to think about it. So the answer is it actually points to the person prototype object. So it actually points to the same thing the prototype property on the person function constructor points to. So eventually, when the object is constructed, this is what it ends up looking like. It ends up having a prototype chain where the dude instance that gets created points to the prototype of the function constructor, which was used to create the dude instance, and again down the chain until you reach null. So now we understand that the person function has its own prototype property, and that prototype property is then added to the prototype chain of dude. We can now add functions to the prototype of person, which is then made available to dude in its prototype chain. Let me show you with an example. Okay, so I've now created another full name function. I've called it full name prototype so we can distinguish it from the full name function on the person pseudo class itself. I've added it to the prototype of person, and it actually has exactly the same functionality as the original full name function. But I've changed the name of it, so let's just call that instead of full name there. And now, let me just hit debug here so we can see what have we actually created. Okay, so if you look on the right hand side here, you can see again we've got the dude with the first name, last name, and this full name is the full name function that we created inside of the body of the person function. But now, if we look at the proto object, you can see in the proto object we also have the function full name prototype. So now when we call console log dude full name prototype, we're going to call the function defined here. So let me continue execution. And there you go, line 16. So there you go, on line 16 we managed to call full name prototype of the dude object. Now how does it work again? If you remember, what happens is it first looks for the function full name prototype on the dude object itself. If it can't find it, it then looks in its prototype, and if it can't find it, it looks in that prototype as again until it can't find any others. But just by looking in the dude object's prototype, it finds full name prototype function and then executes that. The advantage of the second approach, of the prototype approach, is that if you create multiple instances, they all share the same prototype, and the function that we added, the full name prototype function, we added on the prototype. So it just really saves on memory, especially if you're creating tons and tons of these instances. If you are doing that, it's better to add it on the prototype. So with the first method, the method where we just added the full name function in the body of the function constructor, we are actually adding the same full name function. We're repeating it over each and every instance that we create. And as you can imagine, this can bloat up your application somewhat. So it seems that typically putting everything on the prototype of a person of the function is the right way to go. And most of the time I would say yes, that's right. That's the right place where you should be sticking the functions, the member functions for your pseudo class. But there is one advantage to having the function in the body of the function constructor. And that's because in here you can simulate a private member variable. Okay, so that's another feature of object-oriented programming in other languages. That is to say that you can have some properties that are publicly available and some properties that are private. By default, everything that we've created here is publicly available. So I could actually go in and here do dude.firstName is equal to moo. And then if I clear the console and run the code, you can see it's now saying Moo Hussein. But perhaps in our architecture, we want the first name to be, well, immutable, I suppose. Once the person has added it via the constructor, we never want it to change. How do we actually implement functionality like this? So the way we can do it is actually to take advantage of a feature of JavaScript, something we've covered earlier on in this course, and that's to say we can take advantage of closures. So all we've got to do to take advantage of closures is in the full name function, instead of referring to this .firstName and this .lastName, which refers to specifically this property here, instead we just refer to first name and last name as in the parameters that were passed into the function. Okay? So if you remember with closures, since this function in the body of this function needs the first name and last name properties, JavaScript will keep a reference to the first name and last name available to this full name function. Okay, let me show you. Let me go to here and then let's print out the full name function. And actually let me drop a breakpoint here, actually not there. And now let me run this snippet. Okay, so now we are in the full name function. So if we look in the full name function, the dude first name is Moo because on line 16 we set it to Moo. The last name is Hussein. But if you look in the scope, the closure has first name of Asim and last name of Hussein. So the closure here, because we are referring to first name, it's going to return as whatever this variable was when it was passed into the person function constructor. And the same with last name, it's going to just pass us in that instead. Not this .first name, which is Moo, or this .last name, which is Hussein, but the first name, which is passed into the function, and the last name, which was passed into the function. Therefore, if you have your function in the body of the function constructor, and you only refer to the properties that are passed into the function constructor, you can simulate something very close to a private variable. Now you can't implement this kind of functionality using the other method, using the prototype method here, because here you have no access to the properties that are passed into the function constructor. You have to refer to this .first name and this .last name. So that's it. That's really the only example I'm aware of, the only advantage I'm aware of adding functions to the body of a function constructor. It's just so that we can simulate something close to private properties or private member variables by taking advantage of closures in JavaScript.